Okay, so today I'm gonna do a small demo on how to use on LingPipe natural language processing API in Java, and you can go to aliasi.com/LingPipe if you want to learn more about this package and download it and use it in your work. But I'm gonna show you quickly how I can use it to tokenize discharge summaries and also do sentence splitting and part of speech tagging on discharge summaries. So you'd have to write 3 different programs, basically one for tokenization, mine I called base tokenizer, and another one for sentence splitting, and another one for part of speech tagging. So let's run it and show you how to would tokenize this discharge summary. So this you can see it's a discharge summary for Krisny Monroe. The discharge medications are listed here, and as always I'm interested in trying to extract these discharge medication information. So first step is tokenization, and this one of the important steps in trying to extract these medications is tokenization. We tokenize the entire discharge summary, so I'll go ahead and run it. Okay, so you can see it cuts the discharge summary into tokens, individual tokens. Very nicely cuts the tokens. The next part that's very useful is also sentence splitting. We split the discharge summary into individual sentences. So I'll show you how to do that as well. Okay, so using the same discharge summary, let's try to run the LingPipe sentence splitter here to split the discharge summary into individual sentences. Okay, so as you can see, it found 29 sentences, and I cut this discharge summary into 29 separate sentences. And the nice thing is about the LingPipe, it doesn't, like a regular sentence splitter would split basically on whenever it finds a period, it cuts it into a sentence. But medical discharge summaries have a lot of abbreviations such as UMB, dot, and then this sentence splitter is much more intelligent because it's I think they trained it on the Medline sentence splitter. It's actually a Medline sentence splitter. They have a training model, and the LingPipe people, they did a training model based on Medline. So it's much more intelligent. It recognizes medical abbreviations, doctor, dr, dot. It doesn't cut it into a sentence. F over V dot. This usually in a regular sentence splitter would split this into a sentence and then this into another sentence and then this into another sentence. Every time it finds a dot, another sentence, which is absolutely not accurate and not correct. Okay, so using the same discharge summary, let's try to do part of speech tagging. After we have the sentences, now we can label each word or symbol as a part of speech in the context of its sentence, or in the context of the sentence it's in. Okay, so let's learn the part of speech tagger. As well, I should note the part of speech tagger is also trained on MetaPost data, so it's bio data. So it's also aware of a lot of biological symbols and abbreviations and words. So it's able to more accurately select which part of speech is the right part of speech in ambiguous, when there is ambiguity. So a lot of these models, the sentence splitting model and the part of speech tagging model, is a statistical model based on some kind of training data or training text. So we would give it for example, a label discharge summaries, and say, okay, this word is noun and this other word is a verb, and so you have some kind of what's called data mining, where we run a data mining algorithm and we construct a training model that's used to evaluate to evaluate parts of speech in whatever documents or text we give to the model to evaluate, or otherwise called the test data set. Okay, so let's go ahead and run the part of speech tagger. And you can see it labels everything noun and n, so different types of verbs. For example, unknown is some VVN. I'm not sure what it stands for. I think it's some kind of verb. There is also symbol, so the forward slash is a symbol, for example. So added is a verb, for example. Overridden, a noun. Alert, a noun. Override, noun. Seloxib, for example, this one example of the training here, it recognizes a drug name, Seloxib, as a noun, and that usually a regular part of speech tagger would not be able to identify a drug name as a noun, because it's not in its noun database. So honestly, the code is pretty straightforward for the tokenizer part of speech tagger. And the sentence splitter, you just go to the LingPipe website and they have like a simple tutorial you could follow, and then you'll learn how to write this code. And obviously I still have to do a lot of testing on how well the part of speech tagger is able to recognize and annotate discharge summaries. I could do some training of my own using my own set of discharge summaries rather than just rely on their model using the med post and the medline. So there is still a lot of training work I could do. And a lot of testing I'm planning on doing as well. So that's in quick demo of LingPipe tokenization, post tagging, and sentence splitting. And if you have any questions, please let me know. Thank you. Thanks for listening.